Oh, that's the exact one we did yesterday. So let's move on from that one. We did exactly that one yesterday. I was just pulling up the notes to see if we did it. All right, this is the first one for today. This is the first one for today. The one that I had up there a second ago was the last one we did yesterday. It was in case we didn't get to it situation. But we did, so we can move on. Which means we should only have 4 to do today. One of them's really annoying though, so that's why I wanted us to have extra time. That's why we did the quizzes take home. Mm-hmm. All right. So we're gonna finish up 3-6 today. That means Monday and Tuesday we'll do 3-7. Okay.
Please, I'm not getting up.
Here, I got you. I was gonna say you still have broken.
People are so mean. No.
All right, so we're looking for a quadratic that has this as a vertex and passes through that point. The rest of the gobbledygook up there, it just means a regular parabola. We're gonna write it in vertex form.
Do we still have graphs today?
We won't have graphs. Fill page. We'll have one picture, but it's actually a picture from the textbook, so I didn't print it out, mostly because I forgot. So we're going to be working with our vertex form, our ax minus h squared plus k. When we're writing equations, we're not going to use any b transformations. I'm talking now, so the conversations need to stop. Thank you. When we're writing our equations, we're not going to deal with b transformations. Like, they're just annoying. So we're just going to work with a for our any. So when we know it has this vertex.
So minus 0.
Questions, Adriel and Tommy? No. Okay. Let's keep it down, thanks. So remember, this is h and k. So we can put that information in. I know that it's going to be y equals a times x minus 0 plus k minus 2, right? Oh, squared. Forgot my squared. Right? We know that from the vertex. You also don't have to put the 0 there. We can write it as y equals a just x squared minus 2, right? I want to find a, so I can write my equation, right?
Yeah.
Do I know an xy point?
Yeah.
Plug it in. We've got x and y. So we have 25 equals a 3 squared minus 2. I'm going to change my view because I need more space. There we go. Right? You see where all those pieces come from? So 25 equals 3 squared gives us 9. I'm going to switch my a to be this a because 9s and a's next to each other wind up looking the same. What are we going to do next? Add 2. So we're going to have 27 equals 9a. What does a equal? 3. So we'll go back up to our equation, to this guy up here. And we're going to put in that a. Actually, I'm going to use this one right here because we don't need the 0. So our equation for our parabola that has a vertex at 0, -2 and passes through 325 is 3x squared minus 2. Okay. How are we feeling on that one? Okay. Because the next one's a very similar vibe. Okay. A what?
Oh, nothing. Everyone kept saying
It does look like a cocktail shaker. Cocktail shaker is the word for that.
That's what I know.
Not that particular beverage that we're not going to talk about in school because you're going to get the administrators to go, what? I know, but you talk about it like that, they're going to start sniffing. All right, we've got our next one. We've got a vertex of 3, 1 and an x-intercept of 0. Same vibe. We're going to take our vertex form. That's not a pen. Y equals a, x minus h squared plus k. We're working with our vertex form because I've been given a vertex. So we're going to start with plugging the vertex in. Y equals a x minus 3 squared plus k plus 1. Because it's this vertex point right here. This is our h comma k. Every time the vertex of your parabola is h comma k. Every single time. That's why it's called vertex form. It has the vertex in it. But they didn't give me a point this time. They just told me my x-intercept is 0. If I want to write the x-intercept of 0 as an ordered pair, how do I do that? It's 0, 0. X-intercept of 0 means it goes through the point 0, 0. Now I have an xy point to plug in. Now we're going to do that. So we're going to have 0 equals a times 0 minus 3 quantity squared plus 1. Okay? So we have 0 equals a times negative 3 squared plus 1. What are we going to do next? So we can subtract 1 minus 1 equals what? 9a. We squared that negative 3. And again, I have a 9 next to an a. So I'm going to do that so I don't have to be as careful. I'm just switching them. There we go. So how do I get a by itself? Divide by 9. Our a actually equals what? Negative 1 over 9, negative 1/9. So when we come up to our equation to substitute in our a value, we get our equation for this parabola is y equals negative 1/9 x minus 3 squared plus 1. And that's our equation. Okay? There are several questions like that on the homework where you're going to find the a value by plugging in points. Yeah, 24, 26, 28, 30, 32 are all like that. The next one we're going to look at is like the weirdest one on the homework. And I'm just going to say that before I turn the page, okay? Because it's got a picture. The picture that I'm posting is in the book, okay? So this is question 35 in the book. On the homework is assigned question 36. So they're very, 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 very similar. Okay? Okay, okay. So I'm helping you. One of the really hard ones in the homework. And what we're asked to find is the maximum distance. So we're looking for the biggest distance between these two shapes, between my parabola and my line. When we're looking for the distance between, don't think distance formula. When we look at the distance, we're looking at the difference. What operation do we do when we do the difference? Subtraction. Which one's higher, the parabola or the line? The parabola. So we're going to take the parabola and we are going to subtract the line. So we're going to do that with our equations, which I've written up on the top. If you look at the book page, it has them kind of embedded in, but it was really a little tricksy to read on the big screen, so I just kind of pulled them off to the side. So what we're going to do is we're going to take the equation for the parabola and the equation for the line and subtract them. Minus 2x squared plus 4x plus 3. And we are going to subtract the whole line, x minus 2. Okay? You see it? So I'm going to simplify this. Our distance is minus 2x squared. What do we get next? Plus 3x. Plus what? 5. Just making sure. I couldn't tell if it was a 5 or a 9 that I heard. Hey, Ren. Okay. Do we see how that part works? Yeah. At least kind of. Okay, we're looking for the distance, which is the difference, and then we're going to simplify it, right? So what we're asked for is the maximum distance. So this equation is our distance, right? Yeah. So I want the maximum of this. How do I find the maximum? What's another name for the maximum? The max? More different. The vertex. I heard it. So I want the vertex of this. How do I find the vertex of this? Axis of symmetry. You were right. Trust yourself. Have faith in yourself. Okay, so I need the axis of symmetry so I can find my vertex. Because my axis of symmetry tells me what the x value is. So to get my axis of symmetry, that's when we take our the first bit of the quadratic formula, negative b over 2a. So for this particular one, we're going to use the x value of opposite of 3 over 2 times a. So where is our axis of symmetry? At 3/4. That enough? Okay. I was just zooming in so we didn't focus on the picture too much. But that doesn't tell me my distance, because my distance is d. So we need to take that 3/4 and substitute it in to my equation that we made that tells us the distance, right? plus 3 times 3/4. Hang on a second, let me finish writing it, and then I'll ask you where I lost you. Everywhere does not help. I said where. Be more specific. Because when I asked if we were okay on that distance formula, everybody said yes. I heard no no's. That's why I ask. Where'd I lose ya?
Why do you put this in there?
Because this gives us our axis of symmetry. But the distance is what I'm looking for. So I need this. So I need to plug it in here.
Oh.
Okay? Better?
Yeah.
Okay. So I need to have the distance. So I need to plug it into this guy. This just tells me where the maximum is. This is going to tell me what the maximum is. This is where, this is what. So we're going to simplify this. We're going to keep going. What's up? What? All right, so let's keep our -2. What is 3/4 squared? 9/16. All right, it might help us stop getting lost if we stop having conversations while I'm talking. All right, what's 3 times 3/4? 9/4. Plus 5, right? I heard a what? Was that on the door or was that just playing with pencil? I think it was just playing with pencil. All right, let's keep going with our simplifying here. -2 times 9/16. Say it louder. Say it louder. I couldn't hear you. I'm old. I was like,
There are no duck questions. Yeah, there are no duck
Wait, I wasn't asking anything.
Oh.
2 times 9 over 16.
times 9 over 16.
That's what you should do. So that means -18.
You got any questions, Jasmine?
Oh no, 3 over 18.
Only multiply one top. -18 over 16. Yeah. Or you can simplify it. But we can absolutely do that. -18 over 16. Plus 9 over 4. Plus 5. We got to simplify it. We can't leave all these fractions with different denominators here. Not cross multiply. That's if you're going across an equal sign. So we just got to get to the common denominator. Which we can use the 16. There is a way to do it easier because this simplifies. They're both divisible by 2. 9 over 8. Can we get this to have a denominator of 8? Yeah. What's it going to be? 18 over 8. What's this one going to be with a denominator of 8? 40 over 8. Common denominator. See if I can spell it. Close enough. I often wind up with demonators. But I think it actually got denominator, not demonators. So, yes, I believe it is 49 over 8. I'm just far from my book, so I'm dawdling while I say yes. Okay, yeah. We should get 49 over 8. And what that tells us is that the longest line between the parabola and this line up here has a distance of 49 over 8. Which is a fine answer. I'll take it. I do not need a decimal. We do not need to do anything else. 49 is not even, and it's not simplifiable any further. We're going to simplify as far as we can, and then stop. 49 over 8 is as simplified as we can go. Okay? So these ones are long, and weird, and kind of annoying, and aren't you glad we didn't do this after a quiz? Because we have one more type of problem I want to go through. Because there's one more on the homework that's kind of annoying and weird. Okay? Because we haven't done anything in factored form yet. And there's one on the homework that asks you to write an equation in factored form. This is the last one for today.
No.
Yes. This is the last one for today. And then we'll have the rest of the time to work on stuff as needed. Oh, snap. What? Work time in class? Holy cow. Okay? So we're looking at our factored form here. Where are our factors? What do we use? We're going to build this, which means I need factors. We're given this picture. -2 and 4. So we have factors at -2 and at 4. Right? What are we going to do with those? Plug them into what? Into x1 and x2. Does it matter which one's which? No, it does not. So what we have now is we have that y equals a times x minus 2, minus -2, so x plus 2, and x minus 4. Great, I still don't have the equation for it. Do I have a point on the line? Yes. What are we going to do with that point? Plug it in, plug it in. It's a commercial for an item called a plug-in. Like the plug-in? It is substitute. Substitute is the mathematical word. You're right.
Miss Hannah would skin you alive for that.
Plug it in, plug it in. All right, so we're going to take the y value from our point, 4. I don't know my a yet. That's what we're trying to find. But I do know my x value, which is 2. Plus 2. What's going to go in place of this x?
2.
2 again. Substitute it in place of the x. Better. So we have 4 equals a times 2 plus 2 gives us 4. 2 minus 4 gives us -2. So 4 equals a times what? -8. What does a equal? Divide both sides by -8 and then simplify. Okay? We're going to write our equation. And then we're going to be done. Y equals -1/2 x plus 2 x minus 4. Talking down here, because we're writing the generic equation, which means we're back up grabbing this guy because we want to have x and y's for our equation. This was a tool to help us find the a value because we need to have x and y when it becomes our generic equation. And this is the answer for the last one we're doing together today. And that leaves you with 15 minutes. Aren't you glad we didn't try and squeeze in a 20-minute quiz?
Oh my god.
Aren't you glad I didn't say banana? Yes, dear.